Welcome children. This is continuation of exercise 10.2. We are planning to go for 15th question. For doing 15th question, we need to know the two formulas for internal division and external division. We see the line segment PQ is internally divided by R in the first diagram, and in the second diagram the point R divides PQ externally, and the ratio is written as M and N. And OP vector, OQ vector and OR vector are position vectors. OP vector is recorded as A vector, OQ is referred as B vector, OR is referred as R vector. I have not written there. If you want, you can write there. Now the formula for that one is internal division OR vector equal to M into B vector plus N into A vector by M plus N, where M and N the ratio of the division by R. External division OR vector equal to MB vector minus NA vector by M minus N. So only difference is the plus changes to a negative sign. So easy to remember this formula. The explanation of this external and internal divisions, I will do it in a separate video. 15th one. Find position vectors of a point R which divides a line joining P and Q, whose position vectors are I cap plus 2 j cap minus k cap and minus I cap plus j cap plus k cap respectively in the ratio 2:1. So we are going to take the position vectors as OP vector. For simplification, I have written it as A vector, and OQ vector I have taken it as B vector. The ratio, given ratio, I am taking it as M is to N. The internal formula once again I have written there. Now in the place of M I am substituting 2, in the place of N I am substituting 1. B vector I have substituted, A vector I have substituted. Now after simplification we get OR vector equals minus 1 by 3 I cap plus 4 by 3 j cap plus 1 by 3 k cap. Now external formula, similarly I have written the formula and substituted. When I simplified, I get minus 3 I cap plus 3 k cap. Simplification is just taking inside the scalar quantities, multiplying and simplifying. Next, 16th question. Find the position vector of the midpoint of the vector joining the points P and Q. The same way, the position vectors we take it as OP vector and OQ vector. Here the R lies on the midpoint, so the ratio will be 1:1. When you say midpoint, it is actually the point R is bisecting the line segment PQ. Now the same formula, you can write the formula again. The place of M and N I substituted 1 and 1, and OP A vector and B vector I substituted. I got 3 I cap plus 2 j cap plus k cap. You can also simplify, you can also substitute and simplify and see whether you are getting the same answer. Then 17th one, show that the points A, B, C with position vectors A vector, B vector, C vector forms vertices of right angle triangle. Okay, now we need to find, these are all position vectors, so we want to find the vectors. AB vector equals B vector minus A vector. We know we can also write it as OB vector minus OA vector. So this is the same way, formula for your direction ratios too. So I found the AB vector. Similarly, I write BC vector C vector minus B vector. You can remember this formula by having looking into the vector BC vector. The second letter comes first, right? Minus B vector. The CA vector is A vector, take away C vector. So I got 3 vectors. Now I am finding the magnitude. What is the idea behind this proving is right angle triangle? As usual, we are going to go for an Pythagoras theorem. So Pythagoras theorem says square of the hypotenuse is equal to square of the sum of squares of other two sides. So let us see the magnitude. I am finding the magnitude of AB vector, which is root 35. Now we are going to apply Pythagoras theorem, so I am squaring it. AB vector, the magnitude of AB vector, squaring it, square root goes off, so we get 35. The magnitude of BC vector, I get root 41. When I square root, I am squaring it, I got 41. Similarly, magnitude of CA vector, I got CA squared equals 6. Now 35 plus 6 gives 41, which means AB square plus CA square equal to BC squared. So square of the hypotenuse, BC must be the hypotenuse, right? BC hypotenuse, CA should be a right angle. So by Pythagoras theorem, the points ABC forms a right angle triangle. We have proved it. Now 18th question. In triangle ABC, which is not true? Now AB vector, BC vector plus CA vector equals 0. Yes, you go through the line AB vector, BC vector and reach CA vector. Your starting point and initial point are same, so the vector value is 0, so it is true. The second one, B part, AB vector BC vector minus AC vector equal to 0 vector. Yes, it is also true. Why? Because CA vector from C to A you are moving, minus AC vector, when you change the vector direction, then you have to write negative. In this we have already discussed negative of a vector. Negative of a vector, so it is true. C part, AB vector plus BC vector minus CA vector equals 0. This is not possible. This is against the triangle law, because AB vector plus BC vector plus CA vector is only 0. So it is false. D part, AB vector minus CB vector plus CA vector equals 0. It is correct. BC vector can be written as minus CB vector. It's a negative of a vector. So it is true. 19th one, A vector B vector are two collinear vectors. Collinear, you should understand, they are parallel vectors, may be opposite in direction, magnitude may be different. Which of the following is incorrect? Whatever is given, you have to find which is incorrect. Now you write B vector equal to lambda into A vector. Lambda is some scalar, it is given in the book. B vector equal to lambda into A vector. Of course the magnitude can be different, so anyways they are parallel, so it is correct. A vector equal to plus or minus B vector. You think it over. A vector equal to plus B vector, which means A vector equal to B vector, so it is parallel. A vector equal to minus B vector, they are parallel but opposite in direction, so it is correct. So they are collinear. Third one, the respective components of A vector and B vector are not proportional. They should be proportional. Okay, in some books it is given as proportional, then it is correct. If not proportional is given, then it is incorrect. Both the vectors A vector and B vector have same direction but different magnitudes. A vector B vector have same direction, but I think we have to check the question here. Both the, I think it must be an equal vector. Give me a second, let me check in the book. I have doubt in the question. Both the vectors A vector and B vector have same direction but different magnitude. Okay, it is given that A vector and B vector are two collinear vectors. So collinear vectors have same direction. No, it can also have an opposite direction. Different magnitudes can be there, different direction can also be there. So it is incorrect. So according to the new book, it is the C and D are incorrect. Old book, it is given as C is given as proportional. If it is given as proportional, then it is correct. Thank you children. This completes a 10.2 exercise. Thank you.